Thank you everybody for being here. I know it's been a long day, but there are some interesting presentations still going on. And I have good competition for this presentation, even from one of my colleagues from KPMG Romania, from Ștefan Tiță. So if you get bored with my presentation, maybe you go and see his. As I was introduced, I am Daniel Tomescu. I am an ethical hacker / director at KPMG Romania. I do go by the time handle on internet and on every platform where I can register this handle. I do have a few certifications and a few interests. Just to summarize that, I'm into hacking, and I'm just hoping that so are you, because right now we are going to deep dive a bit into some vulnerabilities. I do enjoy looking for new bugs, for new vulnerabilities, but I don't know how it happens. Every time I try to find a new bug, I usually end up finding a cross-site scripting, which is the reason why today we will talk about client-side vulnerabilities, not really interacting with the server at all. But it's no biggie, because a lot of vulnerabilities that are purely on client side can have a rather big impact, and we'll see a few examples as soon as possible. So up next, just a bit of theory, because we have to have a common language. Not much, maybe 3 minutes or 4. We'll see that no vulnerability is useless. In fact, some of the vulnerabilities that are often looked upon with no interest, they can be chained to have a big impact. We'll be hunting for gold. That's a surprise. And we'll see how you can get hacked by GDPR. And it's not compliance. It's as technical as possible, but somehow GDPR is involved. But if you've seen the description for this presentation, probably you're here because I promised you to show live examples of vulnerabilities that are still hackable. I don't know, who wants to see that? I hope you all do. If you've been with DefCamp for 10 years or more, maybe you know that at the beginning on this conference, we had this style of showing vulnerabilities that were still ongoing, still exploitable, and trying to fix them back then was not such an easy task. So, a bit of theory, and because I know this is your favorite part, I'll keep it as short as simple. When we talk about client-side vulnerabilities, usually everything resides within the DOM, and it is a story about sources and sinks. Sources, where exactly can you get your payload from? Is it from within the URL? Is it from local storage? Where exactly can you get it from? And sinks, where exactly does it end up being used, and where can it trigger a vulnerability? This is theory, this is well documented. I'm not going to insist too much on it. For sinks, there is a list, which is way bigger than I could include in a slide. Again, the same for sources. Usually, if you are hunting for such vulnerabilities, you're probably going to follow one of these. And the idea of gadgets, as gadgets were introduced a while back, is this idea that if you have something that is working in an uncommon way, maybe it can help you exploit something in the future. For example, the first example for a gadget presented at DEFCON was a text that was get from a button, and since HTML is a sink, you probably can do something with that if you have HTML injection. It's a lot of theory, I'm not going to insist on that, but the idea of gadget, what exactly is a gadget? I want you to not follow the definition and the theory on the internet, but rather see it as a vulnerability that you can use it in chaining and bringing more impact to the table, right? So it can be anything. Anything can be a gadget if you can use it to trigger something else. So yeah, how you can actually exploit this gadget? If you have HTML injection and you can inject a button with a script payload, that would be your source. And after that, it gets thrown into your sink and it executes cross-site scripting. enough about theory. It was short, I promised. My modus operandi when going after such vulnerabilities, I try to stay within the DOM as much as possible. I try to avoid the server side as much as possible so that the vulnerabilities are purely client side. And this is for a number of reasons. One of them would be that when hunting for such vulnerabilities, I can stay undetected. Nobody from the server side will know that I'm looking into my browser, that I'm searching through the JavaScript files and so on. So I can be really silent in my approach. The second idea would be to use the living of the land tools as much as possible. For example, DevTools within a browser. DevTools, if it's strong enough for the developers to do their job, probably it's also strong enough for us, for hackers, to find a lot of vulnerabilities. And there are a number of ways in which you can use DevTools to, let's say, figure out more about the website than it actually looks like. For example, you can search through JavaScript files. You can search through the memory of the process, so you can maybe find concatenated or decrypted secrets. You can live debug JavaScript execution, so you are as in a debugger, and you can interfere with the normal flow of the JavaScript execution, and so on. I also like to automate and extend what my browser does. And how I do that, usually it's in the form of adding user scripts through TamperMonkey or such extensions, where I try to search for things or for sources in an automated manner. In this example we have here, I'm looking if a website, when it loads, or through my navigation on that website, if it loads a script from a malicious domain, then I will be alerted about that. So I don't have to go manually check every time and at all points to see if such a script was executed. It's rather automated here. And in the end, we have to look for impact and build a nice POC, so whatever vulnerability we find, it's actually well explained why it's impactful, why it matters, why it needs to be fixed as soon as possible. And when I say impact, I do not consider only impact by calculating a CVSS score or, let's say, by some metric it is high or critical, but rather have impact in the websites that matter to you. For example, try to find vulnerabilities, report them, and get them fixed in websites that matter for you. Because it's easy to find, let's say, SQL injection using Google Docs in God knows what website that is forgotten on the internet, but that's not impactful, at least not for you, right? Maybe nobody uses that website anymore, and you're just wasting time. And in the end, you have to have fun, because if you don't have fun, you will quit. You will not follow through all the hard steps that are needed to live debug, maybe obfuscated JavaScript libraries, maybe lose a night or a day searching for something, and so on. So if you do not have fun while you're doing this, probably you also don't have the motivation to get the job done. Next, I will show you why no vulnerability is unexploitable. And I have an example for that. While searching for vulnerabilities on a Zoom website that is currently not available anymore, I have found a few vulnerabilities that have no risk whatsoever. You cannot use them to do basically nothing, right? One of them, it's login CSRF. What this means is that you can forcibly log in another user into your own account. No attacker wants to do that, right? It's useless, it's pointless, but it is something that you can do. And this is what I call a gadget in the extended way of the naming. It's the type of vulnerability that by itself has no impact, but maybe you can use it somehow in a chain. The second one, on the same website, I noticed that it has no framing protection. right? It has no X-frame options header, no CSP, no JavaScript busting, framing, voodoo going on there. So yeah, it can be framed. Again, clickjacking and missing iframe protection, not much of a vulnerability by itself. So it's probably still another gadget. And in the end, because this was a WordPress platform, I managed to enumerate a number of pages, and one of them seemed a bit off. It was probably forgotten by admins on the website. So it would generate an email template based on custom user input. And I've got pretty soon the idea that there is a sink, and I could control the source. So I could probably get cross-site scripting. But here's a catch. This type of cross-site scripting, this is not really exploitable. You would have to manually type your payload into the body, and no victim will do that for you, right? There was no GET request that would reflect the payload into the body. There was no POST request to do that. There was nothing, just a self cross-site scripting. And this is a bit of a bummer, because with cross-site scripting vulnerabilities, you actually want them to be exploitable and to do something with them, something useful, right? But if you combine everything that we've discovered so far, you will see that there is a chain here. First, you forcibly log in a user into an account so that you have access to this page. Second, what was the second vulnerability? Oh, yeah, there was no iframe protection. So you can include this page in an iframe, right? And third, you can trick the user to write everything there, not by typing everything, but by drag and drop. And we have here a pretty short proof of concept, a filmed one. This is where I log in the user. The iframe is invisible. You will not see it, but it will be in the background. And when you try to drag something, I will modify through JavaScript what you are dragging. So from one point to another, my payload will be inserted. And there is a cross-site scripting, right? Through drag and drop. Of course, this is an example where a redirect is happening in the background. The user can still see it. It's not that silent, not that great. And here I come to a previous point I made, that you actually need to look for impact and for proper proof of concepts so that you can show off the vulnerability really in a really impactful way. This would be a second proof of concept for the same vulnerability. But right now, the user sees nothing. The login is happening in the background. You have just a form to log in into, let's say, any website. The iframe is framed just behind that CAPTCHA test. And when you try to log in into such a website where you have a CAPTCHA protection that requires you to drag an image, a correct image, into your box, that image will be thrown into the malicious website. So this is an example about how you can actually build a proof of concept that looks nice, works, and shows impact. But let's look for more. This is not exploitable anymore. Thank you, Zoom, for actually allowing me to show off this vulnerability. They did great. They fixed it in no time whatsoever. And the proof of concept was really useful for them to actually prioritize everything. Hunting for gold. It all started with an alert, because from my experience, I knew that MailerLite had some vulnerabilities in the past, and I was interested in websites that use this JavaScript library. So I mentioned before that I like to automate when I browse through websites, to automate finding a number of vulnerabilities, and this was one of them. This is not cross-site scripting. It's just an alert for me that DefCamp uses MailerLite. So do you think I found something in DefCamp? Maybe, maybe no. This is what MailerLite does for me. It registers a number of post-message event listeners, not the reCAPTCHA ones, the following ones. And one of them looks really interesting. Because it basically allows me, there is no origin validation, it allows me to send a message to DefCamp from any other website, and this message will be processed by this JavaScript code. It's minified, I'll try to explain it. Basically, it will require me to have such a format where I start a string with this ML accounts account. I will go through a tree of functions, and the rest of the payload will be thrown within a function. So I tried for a lot of time to bypass the protections in that function, to trick it to load something that I give it in there. For example, to load something from Google, or to register another event listener that will load something from Google, and so on. And after a night spent on doing this, I did not make it. I did find 2 ways to break my browser, but not a way to exploit this event listener. So, bummer. But there is another event listener, one that initially looked pretty obvious to me that is not exploitable, mainly because there is some validation that you cannot redirect to JavaScript URLs, which is a common thing to do when hunting for post-message cross-site scripting. And also there are a number of other validations in here that you could not do much with. But there is a thing, because you can use the open file to open a URL that you give it through a post message. And in the end, I came up with this format, ML web form redirect, which should redirect the user from DefCamp to another site. The site would not be a HTTPS website, but a data URL, this one. When loaded, this URL will just alert something. But then again, I cannot make it work. Damn it, DefCamp, how do you do that? So there is a protection at browser level that does not allow you to redirect users to data URLs. There was also a validation to not be able to redirect users to JavaScript URLs, so I was kind of stuck in here. But if you read carefully the error message, it says that you are not allowed to navigate the top frame to a data URL, which means that you could probably redirect this to a data URL if it was in an iframe, not on the top frame, but in an iframe, right? So let's try to get DefCamp to load in an iframe. It does not have, it's not that easy. DefCamp has iframe protection. I cannot simply load it in another website of mine. I cannot create such a page, it will not load. Trust me, I tried. But the idea was that maybe I can find a DefCamp page where DefCamp loads itself in an iframe. And by doing so, I could try to send a post message to the iframe, not to the top page, and trigger the cross-site scripting vulnerability in the iframe. And where could that happen? There are a number of suspects. For example, in the contact form, maybe they do something. Maybe they show a map where they iframe a page or something from DefCamp, but there was nothing. It looks like DefCamp does not like to iframe itself. So back to square one. Looking for another attack surface, something that I probably missed in the beginning. DefCamp has a number of other integrations, not just MailerLite, right? And we can see here in the left panel that it has this bar with share options where you can share DefCamp to a number of websites. And by the way, what is with that? Only 61 shares for DefCamp? Come on, I know that you have LinkedIn, I know that you have Facebook, Instagram, and everything. Try to share DefCamp and make it famous, right? it deserves more than 61 shares. But that's also useful for me because with so many sharing options, I also have a tax surface. And there are literally tens of social media platforms where you can share DefCamp. Even TikTok is there, so. For me, the interesting ones would be to actually try to print DefCamp and to make it printer-friendly. There are two options. The second one is the winner one, where I could try to make DefCamp pretty for printing. And what this will do, it will create an iframe within DefCamp where everything is in a nice format to be printed. But the idea is that now I have an iframe within DefCamp. And this iframe happens to register another post message, which happens to take a lot of input from us without checking the origin in any way. And yeah, long story short, if I would send such a payload towards the iframe of DefCamp, it would load a body with an image that would redirect the iframe towards DefCamp. So I would have a mechanism to trick DefCamp into loading itself in an iframe, which would allow me to trigger the cross-site scripting vulnerability. You do have to tell a story to the user to do that, because the user has to manually go to the printer option and try to print the DefCamp page. But who knows? Maybe with enough, with a proof of concept good enough, you could trick anybody here to do that. For example, if I would tell you that DefCamp gives a free invite, maybe a lifetime invite, to anybody that can solve their CTF on their public website, and that the solving of that CTF involves you to go and print the website so that you can maybe see something that you do not see normally, I'm pretty sure a number of people would try to go to DefCamp website and print it using this option. And by doing everything just right, it still ends with another alert, with triggering the vulnerability. So thank you, Andrei, for actually allowing me to present this and not fixing it until now, so you can try and fix it. Pretty cool. And in the end, the hacked by GDPR part, another vulnerability entirely, but somehow it builds upon the ones that I described so far. It uses about the same ideas. And I'm pretty sure you're familiar with these functionalities. It's about the pop-up banners that ask you to accept all cookies or reject them or select which cookies you accept and everything. So you probably know this is on virtually every website out there. You cannot buy anything without accepting cookies. You cannot visit Google or Microsoft or anything without accepting cookies. So why do we have these banners? And maybe you notice that many of them look alike. It's as if developers know how to design those banners identically, right? Well, there are a lot of legislations around the whole privacy sector, and these legislations vary by country, by sector, and so on. So for a developer that wants to publish their website to the entire world, being able to comply with all these regulations and to stay up to date with them is pretty hard. It's a hard job. And that only for a very small functionality to accept cookies, for example. So what they do, they use a third party to do this cookie management, a consent management platform. For each, there are standards. For example, YAB Tech Lab has a number of repositories that pretty much show you how to build a consent management platform, right? YAB stands for Interactive Advertisement Bureau, but the advertisement word is the key word. They also have a division for YAB Europe. They have the standard pretty well explained. It is used by advertisers when they try to target you with a proper ad. And they are also not doing a pretty good job. I mean, they were fined by Europe for not implementing the standard properly. But anyway, they try really hard to look like an authority, so everybody uses their standard within the industry. And when I mean everybody, I mean the consent management platforms, and in the end, every website. So it's cookie consent, OneTrust, Cookiebot, TrustArc, DigiCert. Probably you've somehow heard about these names, right? They are the most popular ones, and this is just for top 10K websites. So you can see that it's about 1/3 of the top websites that use a third party implementing this standard, which is pretty huge. Also, Google offers a certification for their CMP partners, and you can see even more options for consent management platforms implementing the same standard, and so on. So let's just summarize here. We have a lot of laws that differ by country and by region. We have standards for these laws. We have the implementers, the CMP and YAB. We have websites with cookie banners, and in the end, we are the ones to suffer because we have to keep accepting that consent every time. But that's not why we are suffering. It's something else. Well, how do these cookie banners actually work? They register an on-message post-message listener, just like DefCamp did. And they listen for messages from any source which asks them, hey, what is the current consent of the user for this website? Does he allow us to store cookies from this third party, or can we give ads from this third party, and so on? How that looks like is still minified JavaScript. I'm sorry about that. If you like to read it, I like to read it. But if you don't like to read it, just listen to the story. Basically, you get the message. You get a number of properties from the message, the command, the parameters, the version of the standard, and so on. After that, there is a function that gives you the consent for the current user. And in the end, the response is post-messaged back to the source with the user's consent for the website. How it looks like, it's pretty messy, but it makes sense. There is a consent string, there are some properties, but a very visual manner for us to have an understanding about how things work would be for us to look for the pop-up banner if it is open or if it is not. For example, in the event status, we have this TC loaded message, which tells us that the consent loaded properly. So probably you have been to that website before, you accepted all cookies or not, it doesn't matter, but everything loaded properly in the background. If that did not happen, then you get another event status, which is CMP shown. Basically, you enter the website and you get that pop-up banner. This is the status that is received. Which means that probably you are for the first time on that website, right? You did not approve cookies, you did not reject them, or anything like that. But for a third party, that is very valuable information, because that third party now knows that you have visited or not another website in the past. Let's see an example for Cookiebot and user-centrics. This works a bit different. They register an iframe within every website that uses this third party. This iframe registers their own event listeners. They also store the consent for every website that you visit using this third party. They store it in the local storage. Here is how it looks like for a number of websites. In the browser I tested this, I had history for Bitdefender, Dr. Max, and Cookiebot itself, because Cookiebot uses Cookiebot. Who'd have thought? And this is how the event listener looks like. Basically, it's the same story, but with a different flavor. You still get the request for the consent, and after you process it, you take it from the local storage, you send it back to the requestor with a message that shows if you have visited such a website before or not. Again, this affects a lot of websites, and not just small ones. It affects like a third of the top 10K websites, the most visited 10K websites out there, and it gets more and more widespread when you go to smaller websites, because the smaller ones do not have the funds to implement their own protocol for cookie management. So I have 3 demos for 3 of them. Just hoping that the cookie gods will not play me dirty. So these are, oh, you cannot see it. Trouble. Aha, like that. So yeah, these are the websites for which I prepared the POC. So you can try to see if I have visited or not MSN, CNN, ASPN, Spotify, and Flashcore before or not. For example, for MSN, well, I was here before. I accepted the cookies, everything. So no banner is shown. And that is the reason why the website from where I initiated this knows that I was on MSN before. Right? Okay. So they know I've been there. No big deal, right? Well, let's see for CNN. I'm not much of a CNN guy, so I have not been here. A pop-up is shown. But this gives it away that I was not on CNN before. And I get 2 messages saying that I was not there. And there are 2 messages because CNN, for whatever reason, actually uses 2 providers for a consent management platform, and they both say the same thing, that I was not there before. Let's say the same for ESPN. There is another consent option, but yeah, this gives it away that I was not there. You get the idea, right? I can tell if you have been to a specific website or if you have not been there in the past. Okay, maybe let's see another proof of concept for another vendor, and after that maybe we'll see why this actually matters. Okay. The second proof of concept is for Privacy Center, another consent management platform, DDoMe named. And this one is actually pretty common in Spain for whatever reason. Maybe they are from Spain. And it affects such websites. If you are from Spain, you probably know those are the most visited websites out there. They are all about news and sports. But it's the same way of working. You go to a website, if you get a banner, then you were not there previously, right? And I will know that. But let's say for us, if I get a banner, I will try to accept it. Okay. So yeah, next time I go to it, they will know that I was there. So why does this matter? You may ask. Well, I tried to make a list of all the websites that accept such requests from my side and where I can find if you were there or not, and focusing on the banking industry by simply searching for the bank keyword within the domain name. I've got such a list of banks that would give it away for you if you were there or not before. right? So for scammers, for example, this is pretty easy to see where exactly do you do banking, and after that, target you for that specific bank, right? And you know, some banks are bigger, some are smaller, some are more important. What I'm trying to say is that not all banks are the same. And I'm really sorry for giving this example, the one here. I'm really sorry for that. But if I am an attacker and I'm trying to find sensitive information about you, this is the type of information that I am really interested in, right? Because if you look at your internet history and the websites that you have visited, maybe most of them do not tell very much, right? Maybe everybody visits CNN and it's not that much of a deal. But some of the websites that you are visiting, some of them give away very precious information about your interest, about your life, personal life, about your hobbies, maybe. And everything there makes you a target. Now, I try to run this experiment in an older browser of mine. And I have found about 25 websites that I have visited in the past, and asking even the free version of ChatGPT about what do they think about me based on my internet history. They would be able to tell with pretty good accuracy that I am into web, into financial, health and medical, software development, crypto, and so on. So this is pretty sensitive in nature. Well, that was the vulnerability, but what can you actually do to protect against that? Because it's clear that not every website will change tomorrow to not allow third parties to spy on your browsing history. There are actually two things that can be done. The first one can be done by the website itself. They can try to self-isolate from other websites by setting the corp and the coep header. By setting both headers, basically the website would not accept post-message requests from third parties, right? So if you do not accept post-message requests, then the consent is not leaked away. The second thing that can be done, and that is used by, can be done by users, is to actually use browsers that do use state partitioning, which means that at iframe level, the local storage for different iframes will be different. And in the end, you'd be a bit more protected, but not safe. Not safe because attackers could still go one by one through every website that you may have visited and still be able to recompile a list of websites that you visited in the past. So this was about it with this presentation. Do you have maybe any question? I can see a raised hand.
All right.
The third row.
Thank you so much. Give it up for Daniel. And we have a question, if you can please raise the arm. Yep, coming.
Hi, so I'm more of a backend guy, so I have another question. In order to achieve your proof of concept, does it require a user to fall first to a phishing attack so that he goes to your website?
Just to go to a website that I can control. And not really my website, but a website I can control. And I can get that by running an ad campaign or maybe hacking another website that is visited by thousands of users and so on. So if they visit a website that I can control, from that website I can try to launch all these attacks to third-party websites. It can be done in a more stealthier manner, so no browser windows will pop out and disappear. So that was just for proof of concept, but that's the requirement, just for them to be on my website.
Yes, thank you.
Thank you.
All right, thank you. And there's another question here, the lady, right here in front.
So, how exactly does someone get access to my browsing history and get the domains I visited?
through trial and error, basically. There is an algorithm for doing that. Basically, you try to guess within which domain the user has interest in by probing against more common domains. For example, you go for the big news outlets out there. And after that, if you do identify that the user is interested in something specific, as in my example, in software development, then you can search for smaller and more niche domains. But it's a lot of trial and error. Now, that takes time because verifying, let's say, 1,000 domains may take a few minutes or so. But there are also ways to keep a user entertained on your website for long enough so that you can get all this needed time. For example, you can, I don't know, just show the user a video with cats because everybody loves cats, and they will stay there for 5 minutes. And in these 5 minutes, you have plenty of time to go through a lot of domains that might be of interest to you.
Thank you.
All right, awesome. If there's any other questions, feel free to raise a hand. Oh, there's one in the back in the middle. Yep. Right.
Hello. So building on top of the last question, is self-XSS attack enough to gather this kind of information, or do we need stored XSS or something more?
For leaking the consent,
Yeah.
we need no cross-site scripting whatsoever. We just need to have the user visit one of our websites. After that, what happens is that you send this request for consent to another website and you get the answer. There is no cross-site scripting involved. Cross-site scripting is another vulnerability. You don't need that. What I'm trying to say is that basically the whole internet is vulnerable to that. What I've shown you in the second part, the hacked by GDPR part, right? You can ask for the consent that is set by a user on a specific website for virtually any website out there. And that website will give you the consent, even if it was set or not. It will also give you other information, for example, the timestamp for when that consent was set. This will tell the attacker with high accuracy when you entered that website for the first time. And yeah, they will know if you are a long-standing user of that website or you are a new one out there. Attackers can also send other types of requests through post message, not only to ask for the consent, but also to modify the consent of the user. So if the attacker by any means is interested in trolling the user, they can simply go and accept the cookies on all websites that are on the internet, and yeah, basically you'd get a lot of profiling and targeting.
Awesome. Thank you.
Thank you.
Thank you. We have another question over there in the back. Yep. All right.
Okay, so in the last example, since user information is somehow leaked or profiling can be done, do you think this should be regulated similar to how GDPR does it? So this shouldn't happen?
Well, regulated, it is regulated. I'm pretty sure this should not be happening. This is actually a vulnerability. You should not be able to see the consent of somebody for every website out there. Regulation is not really the problem here, but the implementation. And the implementation is that by YAB, that entity that I mentioned in the presentation. That is an entity that is representing the advertisement agencies around the world. So, of course, for an advertiser, it makes a lot of sense to be able to ask for the consent, do something with it, for example, verify if you are allowed to do something or not, and after that show your ad. But when working with standards, maybe it's not a good idea to have the standard being implemented by one of the advertisers. That makes no sense to me, and it makes no sense why every consent management platform out there follows their implementation. that should not be happening.
Yeah, that's true. Thank you.
Thank you.
Awesome, thank you so much. And we have another question, if you can keep the arm up right there in the middle. Yep, it's coming.
Thank you. What if we never consent to those prompts? Are we still vulnerable? Or if we use ad blockers to hide the consent pop-up?
Ad blockers do not block the consent manager once because they had the ads, but not the consent manager platform. So you would still be vulnerable. And sorry, I did not get the first part of the question.
If we always reject.
If we reject every cookie that we try, that does not work for the user because you still end up setting a consent that basically says that you reject cookies. But the consent is still set there, and everybody else can get that consent.
Okay, right. Thank you.
Awesome. Thank you so much. Oh, and another question, if you can keep the hand up. Yeah, it's here in the middle. Yep.
Thank you for the presentation, first of all. My question is, are there any browsers or search engines that we could use to protect ourselves from these? Perhaps things like Brave browser or LibreWolf and so on, DuckDuckGo perhaps?
Not really. So every browser has an implementation that allows ads to be shown at some point. Brave is a bit more restrictive, but the consent, from what I've checked, is still set and can still be requested. Using search engines, different ones from Google and Bing and so on might work. For example, DuckDuckGo, who would have thought, does a good job in blocking a number of third parties, but most of the consent management platforms are still allowed. So the answer is basically no. You cannot really block yourself from having this interaction between websites. And the reason for the answer being no is that a lot of other websites actually use this in a proper manner. For example, if you have a login flow, an auth flow, you go from one website to the other and you have to be redirected, and there is a chain of windows that work together. So you have to be able to have a browser to work like a browser. So I do not have a solution for myself, basically.
No extensions either?
No. You could try to build an extension to block all consent management platforms, but chances are that you will break functionality because some websites only show you certain parts of their website based on your consent. For example, if you did not consent to get cookies for their shopping chart, for example, you may not see the shopping chart at all. Right? So it might break functionality.
Thank you.
Awesome, thank you so much. So, are there any further questions? Oh, there we go.
I really like that this is a conversation about what was on the slide.
That's my favorite thing.
This might also mean that I did not do a good job in explaining everything, but who knows?
Hi, Daniel.
Hey.
So have you tried contacting the implementer or the responsible authorities regarding this issue?
Yeah, I tried once. To my disgrace, I did not follow up on the request. And basically, their answer is up there. It's nothing. So I did not receive an answer from YAB. I did try to also contact OneTrust, the first one the first implementer where I discovered this flow. Again, no answer, but there was also no proper way to contact them. I tried going through the security and the contact at and the default users. They do not have a, I don't know, open disclosure platform or bug bounty program or, let's say, a security contact option that is anywhere visible to a user such as myself. If you try to search for security within their solution, they will just say that they are ISO compliant and they are secure.
Okay, thank you.